Hey everyone, and welcome back to the Hacker News Daily Podcast. I'm your host, and today we're diving into yesterday's top stories that got the community buzzing. Out of 26 stories that hit the front page, we've pulled the 5 that really captured everyone's attention. And let me tell you, yesterday was a fascinating mix. We've got everything from hacking lawnmowers with open source software to a Croatian freediver pushing the absolute limits of human physiology to discovering hidden patterns in prime numbers that have been staring us in the face all along. Plus, we'll dig into some heated debates about web standards and a clever JavaScript library that makes your shaky mouse drawings actually look good. So grab your coffee, settle in, and let's explore what had the Hacker News community fired up yesterday. Story 1. OpenMower. Let's kick things off with something that perfectly captures the hacker spirit, taking a consumer product and making it actually work the way it should. All right, so shifting gears from software to something a bit more physical, let's talk about OpenMower, an open-source lawnmower project that's gotten the Hacker News community pretty fired up with over 500 points and nearly 200 comments. You know, when I first saw this, I thought, okay, another IoT project. But this is actually fascinating because it exposes this weird disconnect in the robotic lawnmower industry. So here's the deal. Apparently, if you buy one of these cheap robotic mowers, like a Yard Force Classic 500, for around $300 to $400, you're actually getting surprisingly good hardware. We're talking geared, sensored, brushless motors, waterproof construction that can handle being outside 24/7, standard connectors, the works. But the software? The creator of OpenMower claims it's absolute garbage. These things literally just bounce around randomly until they hit something, then turn and bounce somewhere else. It's like a Roomba from 2002, except with spinning blades. What OpenMower does is rip out that terrible software brain and replace it with something actually intelligent using ROS. That's Robot Operating System, for those not familiar. And suddenly this dumb bouncing blade machine becomes capable of GPS navigation, systematic mowing patterns, and here's the kicker, no more buried perimeter wires. If you've ever installed one of these systems, you know that burying that wire around your entire yard is just, ugh. Now, the project comes with this pretty intense safety disclaimer, and I'm quoting here, if you are not 100% sure what you are doing, please don't try this at home. All caps, exclamation point, and everything. And yeah, when you're hacking something with spinning blades that moves autonomously, that's probably warranted. This really highlights something interesting about the maker movement. We're all for open source and DIY, but where do we draw the line when things get genuinely dangerous? The Hacker News discussion got really interesting, though, because not everyone agrees with the premise that current robotic mowers suck. Several users pushed back pretty hard, saying their modern mowers already use systematic navigation patterns, not random walks. One commenter, Albert Sire, basically said, "What are you talking about? Most new models already do this." So there's this debate about whether the project is solving a real problem, or if maybe the creator just bought an outdated model. But here's where it gets technical and cool. The discussion dove deep into navigation methods, GPS versus camera-based systems versus those perimeter wires. Turns out GPS isn't as straightforward as you'd think for lawn mowing. You need pretty precise positioning to avoid, mowing your flowers or leaving random strips of tall grass. Some users talked about RTK GPS systems that can get centimeter-level accuracy, but then you're dealing with base stations and suddenly your lawnmower project is becoming a surveying operation. The random versus systematic mowing debate was surprisingly nuanced too. Several people defended random patterns, arguing they actually work better than you'd expect because over time, statistically, they cover everything pretty evenly. Plus, random patterns mean you don't get those visible mowing lines that some people find unsightly. It's like chaos theory applied to lawn care. Oh, and in true Hacker News fashion, someone suggested just not mowing at all. User Pabs linked to research showing that less frequent mowing is better for bee populations. Leave it to HN to turn a lawnmower hacking project into an environmental discussion. What I find most interesting about this whole thing is that it's really active development. The software repository is constantly being updated, even though the hardware repo looks quiet. That tells you where the real innovation is happening. It's not about building a better mower. It's about making the mower we already have actually smart. And that's kind of a metaphor for a lot of tech these days, isn't it? The hardware is often good enough. It's the software that needs work. The creator's pretty bold claim that the current generation of robotic lawnmowers sucks definitely struck a nerve. But whether you agree or not, you've got to admire someone who looks at a consumer product and says, I can make this better, and then actually does it, with open source code that anyone can contribute to, no less. That's the spirit of hacking right there, even if it does come with the risk of accidentally automating your way into an emergency room visit.
Горе мой, горе, локатится от пола, не пущу я тебя, не ястава из дома. Не пущу я тебя, не ястава из дома. Не пущу я тебя, не ястава из дома. Что в горе в этом жизни не сищешь больше. Горе обойдет, а просинаись. Горе обойдет, а просинаись.
And then there's the friction parameter, which controls how much the brush lags behind your cursor. The default is 0.10, but you can crank it all the way up to 1, which would give you infinite lag. Now, infinite lag sounds completely useless, right? But apparently, some artists actually use extreme lag values for specific techniques. At 0 friction, you get no smoothing at all, just raw, jittery mouse movements. But dial it up just a bit and suddenly your shaky attempts at drawing a circle start looking, well, actually circular. What's fascinating is that this isn't even a new concept. Digital artists have been using this technique for years. It's called a stabilizer in programs like Photoshop and Clip Studio Paint. But having it as a lightweight JavaScript library that works with any pointing device, that opens up so many possibilities. The Hacker News community went wild for this, with 560 points and tons of discussion about real-world applications. People are using variations of this technique everywhere. Duolingo apparently uses something similar for their character drawing exercises when you're learning Chinese or Japanese. Nintendo implemented it for the Wii pointer to make menu navigation smoother. There's even this app called Drawmote, which one commenter mentioned, which has turned out to be made by the same developer who created this library. Now, not everyone's totally sold on the approach. There's this interesting debate in the comments where someone named Ish Kebab argues that Kalman filtering would be better, basically suggesting that instead of adding lag during drawing, you could draw with 0 lag and then smooth the result afterwards. It's a valid point. With Kalman filtering, you'd get the smoothing without that slight disconnect between where your cursor is and where the line appears. Another commenter pointed out that the lazy brush technique requires you to make these exaggerated motions when changing direction. Like, if you want to draw a sharp corner, you have to overshoot it a bit to pull the brush around. It feels unnatural at first, kind of like learning to drive with power steering after years of manual steering. But here's what I think is really cool about this whole thing. It's using controlled latency as a feature, not a bug. We spend so much time in tech trying to eliminate lag, reduce latency, make everything instant and responsive, and here's this library saying, actually, what if we add some lag back in? What if that makes the experience better? The technical implementation is surprisingly elegant too. You can integrate it with any drawing application, and it works whether you're using a mouse, a finger on your phone, or a fancy stylus on a tablet. The parameters are tunable enough that you can dial in exactly the feel you want, from barely there smoothing for quick sketches to heavy stabilization for precise technical drawings. Someone in the comments mentioned using it for signatures on documents, which, yeah, that makes total sense. How many times have you tried to sign something on one of those credit card terminals or a tablet, and it looks nothing like your actual signature? This could actually solve that problem. The community also shared a bunch of related tools and libraries. There's this thing called Perfect Freehand that does similar smoothing specifically optimized for signatures. People were discussing hysteresis in 2D space, which is basically the mathematical principle behind why this works. What strikes me most about this story is how it represents this beautiful intersection of arts and engineering. It's not just about making lines smoother, it's about understanding the imperfections in human motor control and designing around them. Instead of expecting users to have perfectly steady hands, the software adapts to work with our natural shakiness. That's just good design, you know? And speaking of beautiful intersections between art and science, let's talk about how a simple visualization tool revealed hidden patterns that have been lurking in mathematics all along. All right, so here's something that caught my eye and really got the community buzzing. The prime number grid story from susum.net. Sometimes the simplest tools can unlock the most fascinating discoveries, and this is exactly what happened here. So the author created this prime number grid visualizer, and while that might sound pretty straightforward at first, Hacker News community absolutely went to town with it. People started playing around with the parameters and discovering these incredible visual patterns that nobody really expected. It's like you give a bunch of curious minds a new toy, and suddenly they're finding hidden structures in mathematics that have been there all along. What really struck me about this discussion is how changing just the column count in the grid completely transforms what you see. When users set the columns to prime numbers themselves or multiples of 30, these striking patterns emerge. We're talking stripes, alignments, these beautiful geometric structures that look almost intentional. One commenter mentioned that it's counterintuitive how many primes there actually are, even when you get into really large numbers. We tend to think primes get super rare as numbers grow, but nope, they're still hanging around in surprising density. Now here's where it gets really interesting. There's this user, MG, who demonstrated something kind of mind-blowing. They showed that prime-based patterns look fundamentally different from random distributions. They created these visualizations that produce what they called hieroglyph-like structures. And honestly, that challenges this whole notion that primes behave randomly. These aren't just dots on a grid anymore. They're revealing some deep mathematical truth that we're only beginning to understand visually. The discussion also touched on something mathematicians still can't fully explain: patterns in consecutive prime last digits. Like, there's statistically significant patterns there that we know they exist, we can see them, measure them, but nobody can really say why. It's one of those beautiful mysteries that makes mathematics feel less like a solved puzzle and more like an ongoing exploration. What I love about this whole conversation is how it sparked people to share their own visualization projects. Some folks brought up Ulam spirals, others talked about evolutionary algorithm approaches. There's even this novel pack method someone developed. It's like this simple grid tool became a launching pad for discussing all these different ways we try to see patterns in primes. You know what this reminds me of? It's like when you're a kid with a kaleidoscope. You're looking at the same bits of colored glass, but every tiny adjustment reveals a completely new pattern. Except here, we're looking at the fundamental building blocks of mathematics, and every parameter tweak is showing us something about the deep structure of numbers themselves. The enthusiasm in that thread, 276 points, 91 comments. It really shows how even something as ancient as prime numbers can still surprise and delight us when we find new ways to look at them. But not all changes in the tech world are met with such enthusiasm. Sometimes progress means leaving things behind, and that brings us to a heated debate about the future of web standards. All right, now we're diving into something that's got the web development community pretty fired up. Our next story is about removing mentions of XSLT from the HTML spec. And wow, this one hit a nerve. With over 400 comments on Hacker News, it's clear this isn't just some minor technical housekeeping. So here's what's happening. There's a proposal to remove XSLT support from browsers, and the community reaction has been, let's just say, overwhelmingly negative. What's fascinating here is that we're seeing this classic tension between the idealists who believe in the permanence of the web and the pragmatists who argue browsers have become too bloated. The core issue is that XSLT, that's Extensible Style Sheet Language Transformations for those who might not be familiar, has been part of browsers for decades. It's this XML transformation technology that lets you convert XML documents into HTML or other formats right in the browser. And while it's not exactly the hottest tech these days, there are apparently tons of legacy systems and applications that depend on it. What's really got people upset isn't just the removal itself, it's how it's being handled. Multiple commenters are pointing out that despite overwhelmingly negative feedback during the consultation period, the removal is proceeding anyway. One commenter put it pretty bluntly. They see this as Google and Chrome basically steamrolling through a decision regardless of what the community thinks. And when you consider Chrome's market dominance, that's concerning. The security argument is interesting, though. The maintainers are saying that XSLT implementations rely on these unmaintained libraries, libxml and libxslt, that have ongoing security issues. Plus, and this is kind of amazing, one commenter who worked on the Blink and WebKit implementations revealed that the current XSLT implementation is incredibly inefficient. Apparently, it converts documents to strings and back multiple times just to process them. That's not great. But here's where it gets philosophical. Several commenters are arguing this breaks a fundamental promise of the web, that content published today should work indefinitely. They're saying, look, we've built this ecosystem on the idea that HTML documents are essentially permanent artifacts of human knowledge. When you start removing features, even old ones, you're breaking that social contract. There's this fascinating counter-argument, though, from a commenter named Code, who actually supports the removal. They're asking, why should browsers include specific template engines at all? Their point is that XSLT could be re-implemented in JavaScript or WebAssembly if people really need it. Why bake it into the browser itself?
You know what really struck me about this whole debate? It's not really about XSLT at all. It's about who gets to decide the future of the web. When browser vendors, especially dominant ones, can push through changes despite community opposition, that raises questions about the governance of web standards. Are we moving away from the consensus-driven model that built the web? And there's this practical reality too. Even if XSLT gets removed from the spec, browsers might keep supporting it anyway for compatibility. But that creates this weird zombie state where a feature exists but isn't officially part of the standard anymore. That's not exactly a recipe for long-term stability. The timing is interesting too. We're in this era where everyone's talking about making the web platform more capable, adding new APIs, making it competitive with native apps, and here we are, removing features. It sends a mixed message about what the web platform actually is. Is it this stable, permanent foundation for human communication? Or is it a constantly evolving platform where old features get deprecated when they become inconvenient to maintain? I think what we're really seeing here is the tension between the web as an ideal, this permanent universal platform,
and the web as a piece of software that needs to be maintained, secured, and evolved. And honestly, I'm not sure there's a perfect answer here, but the process matters, and when the community feels like their feedback is being ignored, that's a problem regardless of whether the technical decision is right or wrong. Now let's shift from the digital realm to the absolute limits of human physiology, where someone just redefined what we thought was possible. Next up, we're diving into something absolutely mind-blowing, a Croatian freediver who held his breath for 29 minutes. Yeah, you heard that right, 29 minutes underwater without breathing. So Vidomir Maričić just obliterated the previous world record, and the Hacker News crowd is having a field day dissecting the science behind this. What's fascinating here isn't just the raw number, though, let's be honest, 29 minutes and 3 seconds is insane. It's how he did it and what it actually means. Here's the thing that's got everyone talking. This isn't your typical free diving record. Maričić pre-breathed pure oxygen for up to half an hour before going under. That's a crucial detail that completely changes the game. See, when you breathe pure oxygen, you're essentially supersaturating your blood with O2, giving yourself a massive reserve to work with. The previous record holder, another Croatian named Budimir Sobac, used the same technique and managed 24 minutes and 37 seconds back in 2021. So Maričić beat him by over 4 minutes, which in the world of extreme breath holding is, well, it's like adding another mile to the marathon world record. But here's where it gets really interesting from a technical perspective. The commenters on Hacker News are pointing out something crucial. It's not actually oxygen depletion that makes you desperate to breathe. It's CO2 buildup. Your body is constantly producing carbon dioxide as a waste product. And when you're not breathing, it accumulates in your blood, forms carbonic acid, drops your blood pH, and that's what triggers that overwhelming urge to gasp for air. So even with all that extra oxygen loaded up, you're still fighting against your body's most primal reflex. One commenter made a really important distinction that often gets lost in the headlines. There's actually a separate record for holding your breath with regular air, no oxygen pre-breathing, and that stands at 11 minutes and 35 seconds. Still incredible, but we're talking about a completely different ballgame. It's kind of like comparing Formula One to street racing. Both involve cars going fast, but the technology and preparation are worlds apart. The article actually calls this achievement as much a conjuring trick as an athletic feat, which is a pretty spicy take. And you know what? They reference David Blaine, the magician, who held this record back in 2008 with 17 minutes and 4 seconds. There's something poetic about a magician holding a breath-holding record, right? The whole thing does have this element of illusion to it. Not that it's fake, but that it's using every possible hack and optimization to push past what seems humanly possible. Now, the safety concerns being raised are legitimate and kind of terrifying. Multiple commenters are worried about potential brain damage from extended oxygen deprivation. Even with all that extra oxygen loaded up, your brain is still going through some serious stress during those 29 minutes. The scary part? There isn't clear scientific research on the long-term effects of this extreme breath holding. We're literally in uncharted territory here. But my favorite comment thread went completely sci-fi with it. Someone suggested we could theoretically create blood scrubbers, basically external devices that would clean CO2 from your blood like dialysis machines do for kidney patients. Imagine that. You could theoretically stay underwater indefinitely if you could just deal with the CO2 problem externally. We're talking about hacking human physiology at a fundamental level. There's also this interesting perspective from one commenter who claims most people could hit 3 minutes of breath holding with just an afternoon of training. And you know what? They're probably right. The basics of breath holding, learning to relax, managing the CO2 discomfort, understanding that the urge to breathe isn't the same as actually needing oxygen, these are trainable skills. But going from 3 minutes to 29, that's where you cross from neat party trick into rewriting the limits of human physiology. What really strikes me about this whole discussion is how it sits at this intersection of extreme athletics, body hacking, and almost performance art. It's pushing boundaries not through technology exactly, but through this deep understanding of human physiology and then exploiting every possible edge. The pure oxygen pre-breathing, the mental training to override your survival instincts, the precise monitoring of blood chemistry. It's like competitive suffering with a scientific methodology. And honestly, the fact that we're even having debates about whether this counts as a real record shows how far we've pushed into the edges of what humans can do. When you need to categorize your breath-holding records by which gases you breathed beforehand, we're living in wild times. Outro. And that wraps up yesterday's top stories from Hacker News. What a ride, right? We went from hacking lawnmowers to make them actually smart, to discovering that adding lag can make drawing better, to finding hidden patterns in prime numbers that have been there all along. We witnessed the community pushing back against the removal of web standards they care about, and watched someone hold their breath for almost half an hour using every physiological hack possible. What I love about these stories is how they show the different ways we push boundaries, whether it's through open source rebellion against bad consumer products, clever software tricks that turn bugs into features, mathematical visualization that reveals hidden truths, defending the principles of the open web, or pushing human physiology to its absolute limits. These were the 5 stories that rose to the top from 26 that appeared on Hacker News yesterday, generating over 2,000 points and more than 1,000 comments combined. The discussions, debates, and discoveries show that the hacker spirit is alive and well, that desire to understand, to improve, to push limits, and sometimes just to see what happens when you change a parameter in a prime number grid. Thanks for joining me on this journey through yesterday's top tech stories. If you enjoyed this episode, make sure to subscribe so you don't miss tomorrow's roundup. Until then, keep hacking, keep questioning, and keep pushing those boundaries. This has been your Hacker News Daily Podcast. See you tomorrow.